So welcome back again to research methods. The chapter we want to discuss today are threats to validity. Threats to validity are a very fundamental topic in any kind of empirical research. Basically, they deal with the question of whether we can trust the results. Therefore, a sound discussion of any threats to validity is fundamental to the trustworthiness of a piece of research work. This is the layout for the chapter today. We will start with a short overview of what is validity. We will discuss a classification of validity. We will discuss then some relationships among different ways to define validity, and we will then summarize and conclude. Let me start with what is validity. The validity of research is basically characterizing the degree to which a research study measures what it intends to measure. This may sound trivial or obvious, but unfortunately it isn't. There are many studies out there that do not really describe what they are supposed to describe. And that's actually also due to the fact that it's certainly not always possible to make this 100%. So to which degree do what our intention and the actual study differ is very important to adequately assess. Validity of research is concerned with the question of how the conclusions may be wrong. So there may be that we draw certain conclusions and in reality that's not really right. We want to understand that, and that's why we are discussing the validity of our research and threats to validity. This is heavily impacted by the quality with which we did our study, but there are many more things that simply can go wrong. And in this chapter, we want to try to lay out like a map. It's not a full detailed discussion, but like a map of what are issues that can go wrong. So in case you later on are in any way involved in empirical work, be it in terms of a research capacity or be it in terms of an empirical based improvement program or something like that, you understand what the issues are that you have to deal with. And that is what we mean with a validity threat. A threat to validity is a specific way in which you might be wrong, and you will be wrong, because there's no way to be perfectly right on everything, simply because empirical work is always an approximation. The validity analysis is the analysis of these possible threats to understand what are the limits of conclusions that we may draw. So why is it really important to analyze the validity of a research study? It's basically fundamental to the credibility or the believability of any findings that we do. Did we really ask the correct or appropriate research question? Did we translate it correctly into an empirical study? Does the study really answer the research question in a non-biased manner? These are fundamental questions, and these we need to at least understand, and we need to understand these issues in order to see and really can make a conclusion on how likely it is we made an error. A strongly related topic or strongly related concept is the concept of bias. A bias is a systematic error that we make, that we all make as humans. It's a tendency to produce results that depart systematically from the true results. For improvement projects, a very important bias is the so-called Hawthorne effect. It goes back to a researcher named Hawthorne, and it relates to the fact that if you do a study and people feel observed, they actually exhibit higher productivity. So if you only check how do they work with a new approach, you will basically always find that the new approach will be better than the old approach. And that has nothing to do with the new approach really being better. It's simply because people see, oh, there's something new. Somebody is trying to measure how good we are doing. So we are, for a limited amount of time, we are putting in an extra effort. And as a result, this new method will seem to be more productive, but actually it's just the people are doing more. That is something which we have to keep in mind if we want to do a study about what's the impact of introducing a new work method. If we don't do it, we will draw completely wrong conclusions. And other things are the secondary observer effect, and so on. A very nice example of a bias is a so-called survivor bias. This picture shows survivor bias in a certain sense. What does it depict? This is a study, I think it was done in World War II, where they checked basically for the airplanes what were the points when where a bullet had hit, and they wanted to learn from that, where is it problematic, where do we need additional armor, and so that's basically showing each bullet that they found on a returning plane. So you see this map and you see, oh, okay, this is where bullets have hit, so we should add armor here. Do we? Really? No, this is completely wrong. These are planes that returned. These are surviving planes. So a bullet has hit, and it was not a problem for them to return. Or well, it may have been a problem, but they still returned. As you can see, there's a cockpit, there are the engines, and so on. We would expect them to be highly fragile, to be the most problematic places to be hit, but we don't see any points here. Why is that? And the answer is survivor bias. These are the machines that returned, and those that were hit in these areas, they actually didn't return. It's not like they weren't hit there. So actually, where we would need more armor is exactly in these areas without the bullets. And that is survivor bias. Simply by looking at things from the wrong way, by having a data set that is systematically changed to a certain perspective, in this case, changed towards those planes only that can survive the bullets because they have not been hit in a significant way, we actually get wrong results. So that's survivor bias, and that's a problem of doing data analysis in this case. In general, bias can be described as problems we humans have in thinking correctly. So today there have been like 175 categories of biases being described. They of course partially overlap, but still there are a lot of ways in which we can systematically go wrong. So there are some systematic problems in human information processing, errors we tend to make, and therefore we should watch out for them and avoid them actively. So research methods that we study in this whole lecture, they actually have the goal of helping you to avoid bias, or at least to understand if you run into some bias, what you can do to counteract and first of all, to notice this bias. So we want to have systems that reduce or minimize bias, and we want to document how we did so that others can identify biases and understand whether there is some way in which a specific study may not be as trustworthy as we would have liked it to be. So bias can lead to certain threats of validity, but it's actually larger. There are threats of validity that are not based on bias. There's a nice map, and you can probably not read it in the video, but you may go to the initial slides. This is actually drawn from Wikipedia. Or basically the data is drawn from Wikipedia, and somebody created it. And it just tries to give an overview of all the different biases. Actually, they are also described on Wikipedia. You find basically for each of these entry a complete article on Wikipedia. So they fall into different categories. For example, too much information. This is problems with human information processing. If we just get overwhelmed by an amount of information, and then we have problems to make adequate or to draw adequate conclusions, or the need to act fast will result in doing certain kind of mistakes in drawing conclusions and so on. So there are many different kind of biases. Here is just a list of one of the most well-known ones. Like, for example, there's a confirmation bias, that people actually look at things trying to find something that confirms the opinion they already have. It may be one of the reasons of all of these strange Facebook posts, that people really try to only look at what confirms any belief they already have. There's a groupthink and bandwagon bias, meaning if I have the impression that everybody else is thinking in a certain direction, people just jump on the bandwagon and come up with similar conclusions. They do not do that in a conscious manner. That's the danger of bias. Anchoring bias is something where I get a relative measure, like I say there's a price of 1 million is actually a low price. Would you take it for 900,000? Yeah, and normally you would say 900,000. That sounds a lot, but if 1 million was just mentioned and that's a low price, comparably to that, it seems like a good offer. Yeah? So this is kind of anchoring bias. So there are a lot of different biases, and it's good to know at least a few of them. It's probably not possible to know every 175 of them, because we all are prone to these errors in thinking. So with that, let's go into an exercise. I have here 3 questions. What is a bias? What is validity? How do both relate to each other? Just stop the video. Let's try to come up with an answer to each of them and then start the video again. So welcome back. Here are our answers. What is a bias? A bias is a problem in human information processing that leads to incorrect results with a systematic tendency. So it's a problem of how we as humans think, and it leads us to wrong conclusions. And they are not statistically distributed all over the place, but they are going in a certain directions. What is validity? It describes to what degree we can trust a scientific study, respectively the results of this study. How do both relate to each other? Biases may lead to threats to validity, so not every threat to validity is due to a bias, meaning there are more threats to validity than can be attributed to biases.